All right. We'll get started as folks continue to join. Greetings, everyone. A very warm welcome to you all to this webinar hosted by the North Central Climate Adaptation Science Center. We are based at the University of Colorado Boulder. I'm Imtiaz Rangwala, co-hosting this webinar with my colleague Heather Yoakum. We bring you these webinars to facilitate a discussion of science, research, and best practices related to adaptation and resource management under a rapidly changing climate and other emerging challenges, with a focus on the north central US that encompasses the Missouri and the upper Colorado River basins. Before I introduce our speaker, a quick word on housekeeping. We are recording this webinar, and you can find all our recordings on our website. During the webinar, all participants will be muted, but you'll be able to unmute during the Q&A period at the end. We, however, encourage you to put your questions and comments in the chat anytime during the webinar, and we'll start with those questions first during the Q&A. We'll end the formal part of this webinar at noon Mountain Time and stop the recording at that point. After that, anyone who wishes to stay on to engage in a more informal conversation with our speaker is encouraged to do so. And now I'm delighted to introduce our speaker for today, Dr. Nels Bjarke. Nels is a research scientist with the Western Water Assessment and Series. His research encompasses implementing locally relevant climate model projection data in water and hazard planning and evaluating drought of all forms across North America and the sensitivity of the classification of drought to the non-stationarity of the climate. Nels utilizes multiple streams of hydroclimate data to build tools and data sets that improve our understanding of how climate change has historically and will continue to impact surface water availability. Nels has a PhD in civil, environmental, and architectural engineering from the University of Colorado Boulder. The title of today's webinar is Practical Guidance for Using Climate Projections in Adaptation Planning. Thank you, Nels. And if you're ready, please take it away.
Great. Thanks, Imtiaz. Thanks everyone for joining today. I'm excited to talk about this project that's been in the works for a little over a year now, and talk about the kind of process that we went through in developing this guidance. I want to thank Imtiaz for supporting this project. Again, I'm Nels Bjarke. I work with Western Water Assessment, and work in the kind of climate services space to think about how we link usable science to adaptation and resilience building. So when during this presentation, I'm going to talk a little bit about the process, how we got to the guidance kind of web tool document that we've made, and I'll give a tour of that a little bit later. But first, I want to talk about just what got us here and the kind of origins, the background of this project. So as you know, Imtiaz suggested, we in this space of the CASCs and Western Water Assessment, we think about using climate model projection data as kind of the underpinning assessment for how we determine what adaptation could and should look like. An example here, this is the 5th National Climate Assessment. And we start with this recognition that a warming climate has impacts on our ecological, hydrologic, and human systems. And as we showed in the figure on the right, things like changes to annual temperature, precipitation, sea level rise, these have impacts on our different systems. And as temperatures warm, as we show kind of here on the left, extremes and hazards can also become more frequent. But there is this persistent challenge in the kind of climate adaptation space. And it's somewhat shown here is that we often think about in the national climate assessments or in the IPCC, which is global assessments of climate change and risk. We think about these larger regional or global domains, but when we're assessing local climate risk, there are some challenges that persist, and these are questions like, one, what data exist that can support local adaptation or resilience building? This might seem like a very high level question, but there's quite a bit of data out there, different methodologies for producing data that's relevant for local management. And as these data sets increase in number, it can be somewhat difficult to keep track of what is coming out when and what is the most useful, up-to-date data set for your purpose. The question of what data should I use? Because there are so many of these data sets out there, and they have different methodological approaches, assumptions, they're built for different reasons. A question that is outstanding for many folks who work in this space, both on the planning and the science support side, are which data are most appropriate. And then the kind of question that links those is how are those choices? So what data should you use when you make that choice? How does that choice impact your assessment? And I want to show a figure here from a paper that came out last year by Megan Oldfather that shows the U.S. National parks and some really nice images. I really like this figure because it shows the kind of ecological geographic diversity across the U.S. And in the same way that we have this variability in our kind of landscapes, in our hydrology, in our ecology, in our human system, so too is there quite a bit of variability in how different climate data products both are methodologically generated, but also how different components of those data sets yield different uncertainties in different domains. And because of all of that, it can be a little bit challenging for practitioners, planners to decide how best to use climate data for planning. Just as a kind of example of this, a very simplified version of the decision space for climate planning. Let's say you are a team, you're a pair, a planner and a scientist, and you've come together and said, we want to use some climate data to do some adaptation planning. There are some decision points that you need to make in this space of when you're developing an assessment of your domain. You need to ask things like what parts of the climate system do I want to evaluate? These are things like variables. Do you have a system where you are assessing the risk associated with a single variable? Maybe it's just change in precipitation or change in temperature would be sufficient. Or maybe, for many like ecological assessments, you might need multiple variables. So this is, a decision point where you have a branching pathway. You could ask a question like, do I need high resolution or coarse resolution data? Most of the time in local risk assessments and adaptation planning, you need more high resolution data, but you must balance that with your computational capacity, how you can manage that data. What kind of downscaling do you need? Downscaling, just kind of briefly, is the process of taking coarse resolution data that comes from our global climate models and making it relevant for more local spatial domains. And this is done in two main categories. They are dynamical, which is using physics to help you downscale the data to a more local scale, or historical statistical relationships. But this is a decision, and each one of those methodologies has an impact on how well the kind of variables that you're trying to evaluate might be represented. Branching from those decisions, you could think, do I want multiple emission scenarios, high future emissions, low future emissions? Is it important to capture a range? You could ask, how many ensemble members do I need? Do I need to use all of the model data that exists? Do I just use a subset of them? And this is all a simplified version of these questions where there are just two answers. The reality is there are many possible answers for all of these questions, and that becomes quite overwhelming. particularly within the context of the fact that, the third question that we mentioned on the previous slide is this choice that you make in each of these decision points might impact your results. And so, how can we approach this really kind of overwhelming decision space? And before I get to that, like, how do we approach this? I do want to talk a little bit about the responses to this decision space that exist and what impact that can have on adaptation. So, worst case scenario is you come up against this difficult decision space and you think, well, this is really overwhelming and we have limited time and resources. So let's not spend our time on this because we're not really certain about these decisions and how best to make them. This can result in no adaptation or adaptation that is not informed by the data that exists. You could have a decision like, well, let's just pick a couple of options. We'll just decide. We think, here's our best guess for which decisions we should be making. It'll be better than nothing. But then this can lead to adaptation that's either based on limited data or potentially misleading information, depending on how you select your climate data. And this can lead to something like maladaptation, which would be adaptation actions that actually have a negative impact on your system. These other common scenarios that these aren't as bad as the worst case scenarios, but these do arise quite often. And that is, well, let's just use the data we already have. This is, quite common because groups will say we have access to, let's say, a data set that we used for a previous climate risk assessment. We'll just use that data set because we've got the code generated and all the data is on local hard drives already, which might end up in a situation where you're using that data that is fit for one assessment, the original assessment in which you got the data, but it might skew your results for another assessment in which the data is maybe not fit for purpose. Another common decision in a similar vein is misplaced confidence in a commonly used data product. So, for example, a team who wants to do some planning might say, well, broadly, the National Climate Assessment used this downscaled data set and they had confidence in it. So let's use it for our local planning because it seems like it is a high like integrity, high value data set. But the results of this analysis might have unintended but avoidable biases because that data set might be generated for purposes that weren't fit for your own. And we really want to avoid all of these scenarios. And then the question is, well, how do we avoid these scenarios when these decision points exist in the climate adaptation planning space? Well, first, I would be remiss if I didn't mention the many climate services organizations that already exist here in the US that can help to support this decision making. I assume that everyone here is familiar with the CASCs because we are in a CASC webinar, but this is the USGS Climate Adaptation Science Centers who focus on ecosystems, watersheds, landscape management. On the NOAA side, Western Water Assessment, where I work, is part of these the CAPRISA programs, which change their name every 3 to 4 years, but we've been around for 25. And we think about human systems, resilience, and adaptation. And then there's the climate hubs within USDA, which have been most heavily impacted by this kind of last year of changes in federal priorities and spending. But the climate hubs serve our agricultural communities across the US. So you can see there's overlap between the domains, but between all of them, there's a deep bench of expertise in this space of making decisions about climate data. And in this project, we worked with the folks in the Climate Adaptation Science Center's Climate Scenario Working Group to develop this guidance. So our approach here, when we are trying to kind of grapple with these kind of big questions, is to first engage with experts in the CASC Climate Scenarios Working Group to try to understand first what are the most pressing challenges when approaching this question of how to select and use climate projection data in planning. So we did the survey and came up with this first result, which gave us an idea of how much guidance is needed for these various topics or decision points in the process. The clear kind of front runner was how best to think about downscaled climate data. Um, how do we appropriately choose between data sets that have similar resolution but different methodologies for generation of that data set? Trying to understand this decision point came out as the topic that needed most guidance, but also topics like how do we handle bias within global climate model output? How do we grapple with coarse spatial resolution of data? Things like scenario uncertainty. Should we be planning for the worst case scenario or a range of scenarios? And then to a lesser extent, things that are more kind of technical related to the climate model structure. So we took these results and had many discussions with our working group within the CASC, and also had some kind of higher level discussions about the goals of this project. When we want to build practical guidance or guidelines for using climate data, we need such guidance to not only consider scientific questions of things like uncertainty, but also real challenges of kind of limited time and resources of organizations. And so, in any sort of effective guidance document, you would want to balance things like these questions we've talked about, model bias, downscaling, with other considerations like the planning team that you're working with may not have the computational capacity or expertise to evaluate multiple climate data sets that are large in size and might take a lot of time. There is obviously, we all deal with the limited time and resources and funding. And so we need to understand what the best balance is too in any sort of practical guidance document between doing our best to create robust assessments of climate risk, but also recognizing kind of these limitations. We also, in this process, we hosted a town hall at the American Geophysical Union in Washington, D.C. in December of 2024 and got perspectives from panelists from other federal agencies as well. So shout out to Amber Runyon with National Park Service, who gave us in that talk a perspective about, ensemble choices and how, using things like an entire ensemble of models that's here on the left versus single projections give you very different views of what a future of, let's say, precipitation might look like. And this has been a challenge for their planning purposes, how to grapple with these differences, and really gave some lessons about how important kind of location specific information is and how including uncertainty within these assessments is for planning. We had Julian Reyes from Bureau of Land Management as a panelist who talked about some of their analyses and how they've used climate model projection data for thinking about risk for species like the desert tortoise in the Southwest US, and gave a nice perspective about how BLM is kind of this super user of climate information and really relies on many of the science agencies like the USGS to make some of these important decisions in how best to use climate projection data. And they use those downstream products in their planning process. So, we can think about how decisions made by folks on the science support side are maybe impacting downstream planning. And we also heard from Jennifer Costanza with the U.S. Forest Service, who gave us kind of a nice presentation during that town hall about how across these different regions of the U.S., you have very different populations of models that have warm versus dry biases in their historical simulations. And so there is potentially a need to both evaluate your model ensemble regionally, and then also the compounding impact that future ecological scenarios can have on their planning and adaptation pathways. So a number of different dimensions to all of this, and all of these agencies are coming up against these similar problems, which is how do you make these decisions and what's the best way to go about it? And so when we were in this, we had done all of these meetings, we had gathered our groups of experts, we had a town hall. Imtiaz and I had been discussing about, how would we make a useful guide, something that is both practical, has the scientific underpinning to support uncertainty for these decisions, but is also accessible. It's a really important component of this. And and many of us who work in the climate services space would realize that simply publishing a peer-reviewed manuscript, checking that off the list, getting the DOI, and then trying to send that out to partners isn't really all that effective because, I have a hard time reading all the papers that I need to read, and that's part of my job when we're working with planners who have limited time and capacity. Sending long manuscripts often isn't particularly productive. So what we've done is we've developed a web-based guidance document that has collated all the information, peer review surveys that we've done over the last year. And what I'm going to do now then is bring this document over. So this is the web page that we have for the document. This is a currently temporarily hosted domain. We're working on getting a full static domain that will be hosted with the NC CASC. But I'm going to just go through this real quick and just show you some of the various dimensions and pages that exist on this web page and how we kind of intend this document to be used. Yeah, it looks like Imtiaz has linked to it. You can access this page despite it being just a temporary link, but there will be a more permanent one in the future. So this webpage, we start off with an introduction, kind of a brief summary of what I've been talking about with you all today about this challenge of the need for practical guidance because the decision space is so complex. And we've got these kind of tabs so you can move around, navigate quickly between the different sections. But the idea is that planners, in combination with whatever science support groups they are working with, can go through this document and work through these different dimensions of decisions that they need to make. So we start off with what we are calling kind of process considerations. So this is before you even approach, what data can I start downloading? It's important to answer some of these questions about, your process. So first and foremost, this is we think about capacity versus complexity. Each team is going to have in each planning organization is going to have a different capacity to evaluate the climate model projection data. This can mean that you might have, let's say you think you have capacity to evaluate a couple of products, a couple of different ensembles. Then you need to think about how does that complexity of your analysis kind of balance with that capacity, and how can you build something that is both like robust and reasonable for your operation. Uh, let's see. Oh yeah, it looks like there's, sorry, I'm not supposed to pay attention to chat. I was told that at the start. Uh, the other question or other considerations we think about is thinking about the dimensions of risk assessment. These are things like sensitivity. So how sensitive is your system to your variables of interest? What are your confidence in the projection data that you're using? And what are the kind of consequences associated with your adaptation action versus inaction? This one in particular is really important. So if you have like a high stakes adaptation decision that needs to be made, you may need to justify in your kind of planning process a more robust analysis versus something that is less high stakes. Um, and then a couple sections about practicality versus robustness. This is again thinking about the kind of scientifically ideal analysis versus your practical approach. And then something we really want to stress in this document is these expert organizations and climate services exist. And consulting those experts and not kind of reinventing the wheel in some of these processes is really important. And so we have, down later in the document links to the expert groups that we talked about previously. After that, then we get into the kind of nitty-gritty of climate model data projection, data selection. So thinking about things like ensembles. On selecting an ensemble of models is something that anybody who's done a climate risk assessment has had to grapple with. And there are a number of different approaches, and they all are well suited for different things. So you could use something like the all model approach. This is where you use all available information, obviously more computationally expensive than using a subset of models. But this is really well suited for things where you might need to capture a wide range of possible futures. You want to know what are the kind of extremes or rare events. You could do things like model screening, which is, excluding models that may not appear realistic in their historical simulation. Using global warming levels is an approach that has been used kind of recently, particularly by the American Society of Civil Engineers has taken this approach to kind of allow for your assessment to be based primarily on how your systems respond to a change in temperature across different models, or you could do a tailored ensemble. This is something that would be more specific to your individual project, and you would rely on kind of expert judgment or scientific expertise to decide how best to tailor your ensemble. So a number of different options. This is not the full list of options. I think most fall within these categories to some degree, but the reason we kind of put these is because these are very commonly applied options for selecting model ensembles, and we try to give guidance on where these might be more or less suitable. Then we get into a section where we give a primer on downscaling. So what is downscaling? Why might you want to use downscale data? And what are some different approaches? I kind of mentioned this briefly earlier, but you can have statistical versus dynamical downscaling and describing what are the major data sets that use these methodologies. In this tool, we link to these data sets so that folks can access them and read more on the kind of details of those data sets. We also, at the bottom of this section, have an additional page because downscaling was this subject that needed most guidance. We have a linked page that talks even more about the different aspects of downscaling, thinking about the different approaches, again, giving more of a detailed description of how they impact your data. A comparison of different commonly used data sets. So looking at tabs of these statistical data sets, their strengths, their limitations. Also thinking about dynamical data sets, again, putting their strengths and limitations here with the idea that, again, the pairs of practitioners and science support personnel could go through this document and get a nice overview of what these different data sets are without having to kind of look up what data set should I be using? Okay, I landed on the LOCA page. Let me read about this. Now, how does this compare to these other data sets? This kind of collates a lot of that information that comes from both literature and our expert team that we've had discussions over the last year. This is a section that many folks who are involved in the downscaling space will be very familiar with. This is like the training data that's used for your climate model projection to do the downscaling. I won't harp on this point too much, but it gives just a brief description of how different observational data sets that underpin most downscaling might impact how that downscaling product affects your future projections. And one section that I really like on this page that came out kind of later in this process is this regional considerations. We call it a checklist here, but we found in the discussion amongst hydrologists and ecologists who come from all over the US is that each region has some very specific kind of nuances and these are hydrologic or climatological or ecological features that introduce uncertainty into your climate model projections. And so we felt it was really important for folks who might be newer to this space but want to use these future projection data in their planning to understand what are some of their regional challenges and considerations that might occur. So we can think about, like, for example, in the Southwest, maybe a challenge is that there's model divergence in how monsoon strength changes into the future, and thinking about aridification versus drought and how that plays out in future model projections, particularly thinking about how model projections that are based on statistical relationships might more or less effectively represent some of these changes. And so we go through the process and got input from folks all across the US to make sure that we included some of the large regions where we felt there were distinct challenges or considerations to be made in this space. I'll go back to the main page and just give a little bit more of the sections for this tool, and then I'll wrap things up and we can take questions. So we have a section here about data access and data tools. Something we found to be useful in this process was folks just wanted to know where can they get the data. And this is where early versions of this were already quite popular with lab groups that I work with. I showed them some of the earlier drafts, and they would ask me to send them this link so that they could just know where to navigate to the different data sets. And we include things like the Climate Toolbox, which is more of a data tool that pre-packages some of these downscaled climate projection data, so you can do analysis on a web user interface. But we also link to things like data portals, like LOCA data portals, the UCLA dynamical data sets, so that practitioners or science support teams with more capacity or technical experience can download those data directly and do their own analyses. Again, I mentioned this section. We have a section on consulting the experts. This is where you can link to different programs and contact your regional CASCs or NOAA CAP-RISA program. We don't currently have the climate hubs listed here because there's some challenges in the climate hub space, but we hope that they are on their way back because we miss our climate hub regional partners. We have a section here. This is just a brief section that will be kind of filled out more on the kind of final rollout of this tool. But just for examples, we sort relevant peer-reviewed literature if teams want to go to the original sources for some of these assessments and understand things like methods for selections, assessments of models, and examples that have been used in planning. And then finally, we link here to a full Zotero library that has many of the manuscripts that underpin some of the text that was written here. And we use, just so folks can access that library, I think it's about 100 papers right now that can give perspectives on this question of how do you select climate data, what are the biases of different data sets, et cetera. And so with that, let me pull this back and come back to my slides here. That was just a quick run through. But again, when we share the report out and the recording for this, we'll share a link for everyone. I saw in my side eye that there were some problems with access, and I was just telling Imtiaz and Heather before that nothing will humble you like trying to understand how to make web access and web domains work on your own, but we're working that out, and we will share that link out when we have a final permanent link as well. And with that, I'm gonna wrap up here and say, today we just talked about how complex this decision space is for supporting climate adaptation, particularly when thinking about how you select climate model data. We've tried to leverage to the best of our ability the expertise that already exists to provide an initial guidance document that can guide teams who are doing this planning through the process and point them to the important resources for making these decisions. And then, this web-based tool will be widely accessible. We'll publish it for folks to use, and hopefully, we can get feedback from both people here, people who access the tool and want to say, hey, like I had this data set doesn't appear in this document. We can collate that information here and have it stand as a living document that will be updated and can be used to help us approach this kind of high level challenge of how do we answer these questions before we even do any of our planning? How do we do these risk assessments effectively? And with that, I can take questions and yeah, thank you so much. Really appreciate it.
Well, thanks so much, Nels. That was great. I would say that, we were initially thinking of just creating a PDF of this thing, but Nels was, pretty, I would say, uh, talented enough to make a website out of that. I think hosting it on a more secure location would be
Yeah.
a piece of cake. Nels, you don't have to do all of that, so we'll help you with that. So with that, I'll open it up for questions.
I'll stop sharing.
I see some questions emerging in the chat. Uh, Folks, feel free to unmute yourself, share your video at this point, and ask questions. But um, yes, how and where the permanent link will be shared? Yeah, that's a good question. Feel free to reach out to Nels or me about it. We hope to, in next week or so, make sure that that is in place. Um,
I'll put my email in the chat. I realized as a bad presenter, I didn't put my contact information on the slide, so I will put that here.
And
Um,
one thing so we'll have a link to this recording, and in that link, slides will be available, and we'll also ensure that the new link to the website is mentioned somewhere there. So if you look for the recording of this talk in a week or so, we hope to get a more permanent link. Heather, am I missing a question here? That,
Are you not seeing them in I'm putting them in the Google Doc,
okay.
but
Would you?
let me know if you're not seeing them. I can refresh it.
No, I'm seeing it.
Okay.
Um, Uh, Adrian had a comment around that that seems that we don't have a comparative analysis of downscale data here, but more broader guidelines. Do you want to say more on else on downscaling? This is a
yeah,
complicated topic, right?
yeah,
Even
yeah.
if it's a
I'm happy to talk about that. Yeah, yeah. I mean, something that we found when going through the literature, and this is the kind of exigence for the regional considerations component of the downscaling guidance section, was that when you look at these comparisons of the different downscaled products, um, they and assessments that have done on comparisons of those, there's pretty significant regional variance. And so it is a little bit difficult to provide very high level, like, here is how each downscaled products numerically differ. And so we link to some of the different analyses that have been done for different regions. And that was one of the pieces of feedback that we did get that we will be implemented in the final version, is having in that regional section links to the manuscripts that do this comparison of the downscale data set where they exist for each of those regions. But yeah, the kind of general answer is there's no analytical high level comparison because it is so regionally dependent that it ended up being a little bit more difficult to clearly state differences across them. So we stuck to discussing really this is why certain downscaled methodologies were developed. Some of them are developed to preserve extremes, others are developed to capture individual events or long-term means. And so we want to be clear about that's how they're generated. And so that's the guidance that we provide, but we will provide essentially links to assessments for regional differences.
thanks for that. Again, please feel free to unmute and ask your question. Any and all questions are welcome. Stefan.
Yeah, I put this in the chat, but maybe I'll just elaborate on the question. So I recognize like this is a really valuable resource, really helps a lot of us, especially boundary role actors, sort of grapple with these decisions and support these considerations and these decisions, in a management context. But also was curious, like, if you all anticipate supporting further requests, and if so, what kind of availability you might have to do so, and sort of what types of requests might you be most willing to entertain?
Well, I guess I could start by saying, I mean, this was a project that was the funding for this wrapped up in December. So this is like we're in the final stages of like publishing this version of this. But I mean, I guess it really will come out of interest and support, potentially from whoever is willing to support those efforts if there is desire to continue updating. I mean, this is something that I really is important to me as a person who works in the climate services space. And so, Imtiaz and I have discussed about like ownership of this, transitioning all of the ownership of the web tool and the libraries over to CASC personnel. And I think that probably once it's transferred over to CASC personnel, my ability to say how it will be updated is probably limited, but I'm happy to support those efforts as they are needed because I do think that it is something that we will continue to grapple with as new data sets come out, new methods come out. This is a problem that isn't going away anytime soon. If anything, it is just getting more challenging to answer these questions. And so, I mean, I think it would be important to support that into the future. But it's a kind of a half answer to half non-answer.
Yeah, we'll go to Diane, Tony, and then Isaac. Diane.
Hi, thanks. Super helpful. I'm with Nature Conservancy. I'm just thinking about like, what's the best way to try to potentially find some of these, like planning level analyses that might have already been done near you, or because like those, and I mean, except like the examples of like the national parks, like some of that stuff comes out in the literature, but a lot of it doesn't, right? Like
Yeah.
once, like the models are in the literature, but I mean, like for example, if we were doing some adaptation planning for a preserve and, you know, a similar preserve, say, owned by Audubon, like also recently did similar adaptation planning, like we would have no way to know that. Um, do you have any sense of like, are there any hubs of like, so like, how do we stop like each, sort of practical, like on the ground group reinventing the wheel every time? And obviously you have to redo analyses as new models come out, but I'm just wondering if that came up at all in, when you were thinking about this project.
Yeah, I mean, I will say I don't know that we thought so much about the this idea of maybe like a common space. This is good. You can correct me if I'm misinterpreting this. I guess the thing that I'm hearing from you is that maybe there's a need for like a common space where folks can say, "Hey, we've done this assessment in your backyard, essentially. You might do something that's very similar. Why? Let's not reinvent the wheel. Let's like leverage these." And I think that is something that could be really valuable and would just require buy-in from folks who are doing these assessments, particularly if, I know that in the kind of academic literature space, there's this requirement for like publication and making data availability, but many of these planning processes are also happening in private sector spaces where there aren't these requirements for publishing data availability. And so, yeah, I mean, that would be a challenge because you would just need to make sure that, or you would want to get appropriate buy-in, and whether or not that would happen, I guess, is just up to kind of the community desire to have that information more public. A kind of related point to your question that I think is really something that we've discussed a lot is the need to have more of these things. Like the climate toolbox is a great example of data that is packaged ready for analysis really quickly. That kind of thing, having more of that being developed for some of these other newer data products, supporting the integration of those assessments into newer data as it comes out, I think is really, really useful. I mean, I have experience doing all of this kind of climate model data analysis, but I also use the climate toolbox when I need, hey, some quick figure for a presentation that'll help me kind of make this point. It's incredibly valuable. And so I think that as like a community, supporting efforts that make that kind of data more accessible is one of the ways that we can approach this challenge and make the threshold or barrier of entry to doing some of these assessments lower, I think is one of the solutions I see.
Oh, one thing I'll add, and Diane, that was a great question. I think there's value to different people doing this work and using different methods, and it's always be important to see what their findings, how findings are different for similar systems, similar regions by using different approaches, because I think we should not have a false sense of confidence to using a single method. So, um, yeah, I mean, in drought community, they use this term convergence of evidence, and in climate, in I think future climate assessments, impact assessments, I think some of that, this convergence of, yeah, we are finding similar risk emerging using different data sets and methodologies because we realize that no data is perfect, no model is perfect, and they're all helping us assess risk. And so there's, yeah, a climate toolbox. I just love it. I use it all the time, but sometimes I also tell people what you should not use it for. And that's where going back to Nelson's comment earlier that please consult regional experts. So I just hope that these different planning efforts are reaching out to different experts. And I think that if that one common denominator is there, that would really help to make this effort more robust across the community of practice. I'll thank you again. I'll pass it to Tony. Nice to see you, Tony.
Hey, MTS, nice to see you too. I'm calling in from Germany, so I used to work at the North Central, no, the Northern Plains Climate Hub and the South Central CASC. Thanks for this presentation, super interesting. And I want to ask a question that's maybe a little, I don't know, I don't want to diminish the effort here, but I'm kind of curious what if you trialed this with stakeholders and what they said about this. Uh, the the reason I'm asking this is if I were a stakeholder with like a specific use for climate data in mind, like I don't know, an ag producer or something that wants to plan, or someone that wants to do agroforestry, wants to know what kind of trees to plant. I have a specific use in mind, and I feel like you're giving me good guidance for what models are good and what are maybe not so good, or what kind of data is good or what not so good. But I wonder if there's a way to like say like I'm this person and I need data for this purpose, and then you tell me the two models or something that, or the two types of data that I should be using, or the types of data I shouldn't be using. I see the climate toolbox all the time and I use it, or I really like it, but I feel like just linking to that sort of um, still makes it difficult for me to pick the right kind of information, right?
Yeah. I mean, I think that yeah, I totally appreciate the question. And I do think that part of the I mean, this is our why we might sound like a little bit of a broken record is that like the guidance components that really it's, you need to consult your regional experts. That's quite important, I think, because providing a like some sort of like automated like input, I'm a forester and I want to make a decision based on this, here are the best models, it becomes so specific, I think, for each individual purpose that it is a little bit it is a little bit challenging to collate all of those very kind of niche specific questions into a response that would feel honest, I guess. And I think that are also is like some in many of our discussions in this group, there was concern amongst several of our experts that we aren't prescribing necessarily models that are like winners or losers. This is the best model for this. This is the best model for this. Because when you get into that space, that is really, I guess, quite dependent on, like we are saying, kind of your specific need or planning procedure. So we're trying to strike that nice balance here, but it is admittedly difficult. And I think that I guess to your question of like if you were a planner and you want to use kind of models in planning, I think that many of these resources, particularly within the context of the US, these climate services groups have personnel and capacity to engage in these questions. And I think that that is like really where what we should be doing is leveraging those uh, expert specific regional experiences and knowledge of how these data set work in different regions. So I guess I understand the motivation for the question for sure, but I think that it becomes quite difficult when you get down into those very specific situations to provide really direct, like here, use this model, don't use this model, because it's so variable.
Yeah, I see that. I mean, I know the challenge. I wonder, did you trial this with like stakeholders that maybe requested this, or was there, did you get any feedback of community planners or emergency managers that about what they thought?
Yeah, I mean, most of our like development feedback in the later stage of this process came from folks who are across different like climate services space and work with those groups who do the kind of science support side of the planning, with the idea that this document would like serve as a collective thing, not just for like a emergency manager to just take this and then do their own analysis potential. I mean, it's possible they could, but so we haven't directly sent it out to say like individual emergency managers, but that's a potential next step for getting feedback on the utility of it. Or not just emergency managers, other folks who are doing planning.
Thanks.
Yeah.
There was a lot of questions in the chat. I'll go to Isaac's question. Do you have any thoughts or guidance on how often to update climate adaptation plans and analysis based on new data, updated projections? Is there a rule of thumb?
Sorry, could you repeat that?
Yeah, any thoughts or guidance on how often to update climate adaptation plans analysis based on new data, updated projection, like when CMIP 6 comes and data, some plans maybe based on CMIP 3 or CMIP 5, for example, or new data sets like new downscaled data sets that come about.
Yeah. Yeah, I mean, it's an interesting question. Something that a discussion that I have heard in the space of this is more kind of larger scale thinking about like the CMIP models and the IPCC reports is that when you kind of transitioned between CMIP 5 and CMIP 6, there were some changes amongst the model ensembles, one notably that there was this emergence of more what we would call hot models that are more sensitive, but kind of there were many regions where there was all these model updates done. They reran the analysis, the simulations, and there really wasn't much of a change. And so they were writing these new reports, and they were essentially saying, well, things, there are some specific niche differences, but for the most part, our projections persist. It's getting kind of warmer. We're seeing these different impacts like we showed in the previous generations of the model. And I think that that can be kind of a challenging thing to approach, particularly for planners who might have smaller domains or limited capacity to update things every 5 years or so. I mean, it's not a zero cost thing to update these plans. And so I guess as a rule of thumb, I know that many organizations that I've worked with here in the Western US, they think about like decadal climate planning. They update their future water planning on a 10-year time horizon. And I think that Something along those lines is probably a pretty reasonable thing to do. This is me kind of more kind of ad hoc talking about how others are doing this and my kind of expectation. Also, there is this question about long-term versus near-term planning. How much do you expect that in the next, let's say, 10 years, differences in your emissions pathway will dramatically change the impact of climate on your system? There will be an impact associated with the climate, but most climate model projections, regionally and globally, don't diverge significantly until about mid-century. And so if you're capturing the scenarios that you think you should be planning for in your analysis, and let's say 5 years, a new ensemble of models come out, as long as you're planning for what you expect to be the kind of range of extremes or your range of predicted futures, it's likely unnecessary to do these updates every like 3 to 5 years, probably more on the like 10-year time horizon. But it'll really depend on what time horizon you're planning for. If you're doing 5-year planning, 10-year planning, 50-year planning, that will inform that decision a lot.
Yeah, I just want to add that most guidance documents you'll say, at least in the current times, we have the CMIP 6 set of models and CMIP 5 set of models, and they say, yeah, both are equally applicable for most purposes. Also, having said that, any new analysis that you may think of doing, a new assessment should reconsider previous assumptions, uncertainties that you then deal with. I think those may be more important to consider, not only uncertainty in climate, but uncertainty in your systems that you didn't tackle clearly previously. I think, yeah, so one should be more nuanced about future assessments or new assessments, just not climate, because it may not give you a major difference from your previous work if you keep the same assumptions and uncertainty. Yeah, if you don't tackle them differently. There are a few more questions here. But perhaps what we will do is we'll stop recording at this point and move into our informal session if folks would like to spend a few more minutes. Please feel free to do that. And thank you again all for joining. And can we thank Nels once again for his presentation? Thank you, Nels.
Yeah, thanks for having me.